Audio Jungle.
Let me talk to you about the data revolution that is happening. You might have heard this from us or many of the other industry players also. There is a lot of data coming in. The world is shifting from people-driven network to machine-driven network. An average human being creates 1.5 gigabytes per day. An autonomous car would be 4,000 gigabytes per day. Look at smart factory, 1 million gigabytes per day. The order of magnitude higher amounts of data that is getting created would mean that we need different techniques, different software, different way of thinking to store, analyze, and create learnings from that data. And that's one of the biggest reasons why artificial intelligence is coming into play. And what we see is workloads like artificial intelligence and high performance computing in general are rocketing globally and in India.
I'm going to do a very simple step back and say this is what life was and this is what it is today. So if you look at it and you kind of just go horizontally, if you were developing applications 10 years ago, a decade ago, you actually first started by saying it's going to run on this system. You were very aware of the computing capabilities of the system, the I/O capabilities of the system. Hell, you may have even written some of the drivers and the portions of the operating system in order for your application to work. Today it is, and increasingly will be the way things are in the future, is you're writing for a cloud. And that actually is both technically true and metaphorically true as well. You will lose, per the cloud, the visibility to exact piece of hardware that you're running on and the exact characteristics of a highly engineered system. You will run and write applications for a trust view or an abstraction that you believe will be given to you per an SLA. Okay? Very different than saying, I know, I can trust the system, I understand what its limitations are, I know how to debug on it, to an environment which is not always the environment you build the application in.
I would like to share government's perspectives on how do we see this movement rolling out, this moment unfolding. I'm sure all of you would be aware that the national government has a flagship program called Digital India, under which a gamut of activities are going on. And I would also like to let you know that while there are 29 states in our country, not every state is equally bullish or equally progressive or equally proactive in taking up different components of Digital India.
Let's speak about HPC and the way we see HPC today. Thinking about application and the efficiency of application, a few years ago it was quite easy to get more and more efficiency on the application just because technology was evolving. In terms of processors, the processor was more and more powerful. We had more cores, more clock speed. The interconnect were faster and faster. Storage also was faster and faster. And it was quite easy when you were accessing a new system, a new supercomputer, to get more efficiency on your application. Thinking about the next steps, about 2020, 2022, and the exascale objective we have all in mind, it's a complete different challenge because it's no more about only computing power, but it's also about energy efficiency, energy envelope, and we need to think differently, and we need to think through efficiency.
The quantum computing world has enabled to develop some algorithm, like for example, the Shor algorithm, which is basically the integer factorization. And this is, well, the quantum computing speed up is not proven for every algorithm, but it is proven as being a quick, real game changing into the future and a clear motivation to develop quantum computing. There are several domains of application in which quantum computing will be able to boost the application. The first one I discussed about is for sure cybersecurity. and cryptography, as cryptography rely on integer factorization, which will bring, I would say, exponential speed up to the algorithm. The second one is the pharmaceutical industries, which for sure might benefit the first one from quantum computing by decreasing the time to discover I would say complex molecule or larger molecule than today. And this is thanks also to the natural quantum properties and the implementation of the Hamiltonian simulation in quantum computing.
What benefits do I get by bringing larger computers, spending more money, burning more electricity, etc.? You know, that's a fairly good question a common man should ask. When the models get improved in terms of improved resolution from maybe 10 kilometers to 1 kilometer to recently I met a scientist. His idea is to run entire Indian subcontinent at 100 meters resolution. That's the goal that he has. So when the resolutions improve, it means exponentially the computing performance needs improve. Not only that, earlier probably once a day is when the people used to run their forecast. Now the frequency of running the models, running the forecast cycles are improving. I mean, they're more frequently they are being run.
So this is what people feel, right? So there's a big disruption that's going to happen. 87% of the people say that it's going to impact them, and then 44% say that they are prepared for it. But are we? How many people feel that we are ready for digital disruption? Are they okay? But still but to be honest, like I'm not sure we are sincerely there yet, but we need to do a lot of things before we actually go about doing this. So let's see what happened to one of the big digital disruption examples. So everybody knows Gillette. So Gillette had this thing with all these blades and every stuff. He felt that, so he is ready for digital disruption, and he said like, I'm ready. And then he said like, okay, I'm there online. So which he felt was a digital disruption. Do you feel that being online is a digital disruption? Okay. So people felt the same. So Unilever is the main competitor for him. So he bought something called as Dollar Shave Club. And then he started floating his own online portal. So where he said pairs of blades, this kind of blades, that kind of blades, and all these stuff. So which made Gillette a little bit go behind the scenes because he doesn't have anything like that, and his competitor has come with something, which means that something is changing. Your competitor is changing, right? Your competitor is doing that.
Since time immemorial, there's always been this run between humankind, the mysteries of nature, and science and technology, right? Right from the human body to ailment, to illness, to cure, the entire medical science trying to understand how the human body works, to what at one point in time, how could Sanjay sit in one corner and relay Mahabharat back to Dhritarashtra was a mystery, wasn't it? Now today, would it be a mystery if I say that I can watch what's happening in a cricket match in South Africa, sitting right here? So science and technology has been doing that all this while. And one of the next bits of science and technology which is going to change humankind, impact in a big way. If you look at some of the big changes that has happened is, what should I say? Let's say desktops, right? Computer on every desk really changed the way we worked, really changed the way we innovated, and brought about a huge change in the way the human race functions in this world.
Let's talk about the growth vectors, right, in high performance computing. You can replace high performance computing there with enterprise, HPC, AI, cloud. You look at these growth vectors. I want to talk about two different tangents here, right? The first one is something I talked about yesterday. We have this whole exascale approach where we are looking at today's technology of processors. 3 years from now, what is going to build an exa class of system? That's going to drive all kinds of new applications, not only in the scientific area, but also in the enterprise area. Okay. The other aspect, which is the focus of a lot of this conference and the focus of a lot of people around, is really the whole convergence of artificial intelligence, high performance data analytics. You'd have seen the buzzword, big data, and then the usual modeling and simulation, which is there in high performance computing today.
High performance computing and AI at Intel, one of the things we hear a great deal about is what is the difference between HPC and artificial intelligence? How are they different? How are they the same? And what I want to talk through this brief discussion is about the intertwined futures of it, and then maybe start to take a look at how we can come up with a platform for handling the workloads of today and the next 20 or 30 years before we get to quantum. One of the things that's interesting that happened yesterday at some of the Twitter channel back and forth was trying to is AI here? There's a lot of buzz about AI, but is AI actually real? I think one of the alarming statistics that people wake up to is that 90% of the data in the world has been created in the last 2 years. What's actually interesting is that's a trend that's been going on for over a decade.
So that's the day job. So all the cool stuff you guys build gives us the opportunity to play, which is always very nice. So I want to talk to you guys about how we utilize all the kind of processes for Borrowably 2. I was actually here about a couple of years ago talking about the same kind of thing for BB1, but we had a few kind of switches around for the second one, specifically primarily down to the environments. Now the environments themselves for the second film were a lot more organic. When you're coming to dealing with foliage, real world elements, that kind of stuff is very, very difficult. It's very computationally intensive, very, very problematic. It's not kind of hard surface reflections for ray tracing, very straightforward. When you're dealing with organic matters, you've got permutations, you've got subsurface scattering, you've got light penetration on things, and it's very, very, very computationally intensive.
So as I told you, it sits between your compute as well as between your compute and parallel file system. What it does, it absorbs random as well as sequential data, whatever your compute throws, at a very, very, very high speed. Okay, it acts like a extended cache, and your compute never knows that there is something like fast cache or flash kind of storage sitting between your PFS. And backend, it aligns same I/O sequentially to your parallel file system. The throughput of the parallel file system needs to be only just 1/4 of your IME system. Another advantage is what IME gives you is, unlike typical HPC architecture or storage parallel file system, whenever you consume more of the space, your performance gets degraded, right? Let's say if you consume more than 70% or 80% of the capacity, performance slowly degrades. But here, with the fast cache sitting on your compute, irrespective of the capacity utilization, your performance remains same throughout.
Differentiating. What really differentiates you is what you are bringing onto the table, the data, the algorithms that you want to use, and then tie them together to come out with the model. Right? That's basically where AWS is trying to change how you look at AI. Right? ML is too complicated for everyday developers to use that. Right? I am myself, being a management accountant, I probably get dreaded when I think about algorithms and mathematics. Right? But I am a born in the cloud enthusiast for AI ML, and me talking about it today is the proof enough for that. Right? So Amazon has given out three, basically the stack, the AI machine learning stack in AWS, falls into three categories: the application services, the platform services, and the frameworks and interfaces.
A lot of these examples that we're talking about are actually built by the customers, and we actually provide those platforms for you to be able to do it, whether you're going to be doing it from starting from the services or to actually going into flexibility into a more aspect. For example, if you just take this one, it really talks about the application services, platform services, and frameworks and interfaces as well, really about where all you would like to start your journey on the machine learning one. So you can actually, at this layer, which is infrastructure layer, you can actually choose what frameworks you want to choose and then actually deploy it to a specific compute, and which is really customized for such workload. For example, NVIDIA has a Tesla V100. You can actually go up to almost 1 petaflop of compute.
So this is some of the MPC proprietary tools. So first one is POPI, that's physics-based API for rigid body simulations, where in the movies you see a transformation happening that's out there. Second one is the famous buffalo stampede scene from Jungle Book. That's our crowd simulation software. And what it does is, so initially when the crowd simulation was getting simulated in the movies, then it was all done shot by shot simulation. So now we have taken it that just shot by shot simulation is now extended towards the sequence, and that's a procedural sequence algorithm rendering which happens, which is used. The third one is our fire simulations. So wherever you fire, creating a CG fire is extremely complex. Creating that in a very traditional format is extremely complex. So we have an algorithm which creates fire simulations.
What do you think is the value chain for AI looks like, and are we really seeing that developing in the Indian context? From an incubator perspective, how do you see the value chain shaping up?
Sure. Prior to answering that, given that it's a DevCon from Intel, a quick show of, obviously everybody here are innovators, but quick show of hands as to how many entrepreneurs or wannabe entrepreneurs, CEOs, CTOs.
Wannabe, if you say, I will say.
Yeah, that's a good number, and I wanted to set the tone specific to the value chain as to a lot of innovators are not necessarily entrepreneurs, and a lot of entrepreneurs are not necessarily innovators. Right? Most successful entrepreneurs are people who build significantly scalable businesses which grow, have the potential to grow non-linearly. So with that in mind, the 4 ingredients that any ecosystem needs to complete the value chain is a set of people who provide capital, a set of innovators, people who can scale a business, and government that allows for policy. In this value chain, the entrepreneurial view has fundamentally, in the context of AI, has been access to data. And entrepreneurs are a breed of people who have no clue where their next paycheck is going to come from.
Right.
Which means they zone into the problem. They don't think necessarily big as far as the problem is concerned, but the solutions are big. So the gap that exists in the, so that's number 1, accessibility to data. Number 2 is access to cheap and scalable compute. Fortunately, the latter is being addressed. Suspects like folks on my left and right have tackled it. And I think access to data is where there's a big gap in the value chain for entrepreneurs.
Okay. And now coming to some of the use cases, the questions that you asked, right? How many of you use Tinder? Right?
Nobody's raised.
I would like to see more hands. How many of you use Shadi? Right? In India, I would say more Shadi than Tinder. But for example, Tinder as well as Shadi, they run deep learning algorithms to build matchmaking between 2 individuals who, if you yourself go and try to search, you might not find the right match, right, in the same database. But using those models that are built in, using what you are doing on the platform, what kind of searches you are doing, it trains and creates and brings those connections to you. So again, use cases, different industries, you can solve different problems. You go to any enterprise, head of marketing, head of sales, would you like to see your marketing campaign effectiveness improve, right? And I'm sure they will say yes.